Thank you, Aitor. Good morning. I'm glad to present this ongoing project using LiDAR and airborne laser scan to improve the point cloud in a mixed forest plantation. Which one? Okay. So, light detection and ranging. What's LiDAR? What is LiDAR? LiDAR is a technology that uses light to measure distance. And in some cases, it's possible to measure speed. Nowadays, many different applications are using LiDAR, and we don't even know about this. For example, to self-drive cars, it's one used. Even cell phones nowadays, they come with a LiDAR sensor. But the main difference, the LiDAR for forest sector, it's the amount of point, the point density, and also the precision of this point. And for the forest sector, we have many different types of ways to scanning. We can scan by airborne with airplanes. Nowadays, it's getting more possible to get a UAV also with a laser scan. Terrestrial, it can be a fixed scan or a mobile scan. Each way of scan, there's a slight difference, of course. Some ones are more expensive, someone's cheaper, and some ones can cover our large areas, other ones small but with high density points. And also, it's possible to get LiDAR data from the space. What we get from this mobile laser scan, it's a mess of points. It's like when you see something that hard to understand, you think it's wrong, because we got like 100 millions of points to get something out of these points. So what do we want to get from this point? We want to get forest data, diameter, tree heights, slope of the terrain. We can get many diameters at different heights. The quality of the tree, if the tree is straight, if it's bent, we can take carbon volume, under the ground shrub, many different variables from this data. But how to get this data? How we can go from a mess of point to something usable that we can improve the forest sector? First of all, collect the data, georeferencing the data, merging point clouds, filter some data, remove noising. Yes, it's not easy, but it's not done yet. We just pre-process the data, just make it a little bit better. So how to get this point into segmentation parts, like we want to get the branch, the stem, the volume, the diameter. So we have to train a model. And creating training data, prepare the data for processing, pre-processing this training data and see if the results are acceptable, and training the model, and after run the full data with this trained model. And after this, yes, it's hard, but it's possible. The idea of the LiDAR is recently new technology, so we have a lot of challenges here to overcome, about like timing scan against data size. We can scan more large area, but we have a big data. With a big data, it will be more hard to process this data. So we have to balance this. Nowadays we're facing a problem to merging the data. So can we scan only one time the whole martelloscope, or we can split this data? If we split, we have problem to merge the data. Overlapping also, it's what's the overlap I should get from this point cloud? And also about improving the quality, it's the idea of this paper. We have a mobile laser scan, and we are improving this data with airborne laser scan. And ways to process and get a better data from this point cloud. It's also a challenge that I want to solve in my PhD. Nowadays, what we are doing, we are performing 3 different scans in a martelloscope, using different numbers of control points to georeferencing this point cloud. It's also, we don't have a paper telling how many points we should use, so we can take more, we can take less. We are doing different ways to get these results. And merging the points, it's also, so far, the biggest challenge here. And describing the techniques to processing this data. And after, we have to combine 2 different point clouds. They are totally different. One from the handheld and another one from the plane. Compare the data with the field data to see if this point cloud is giving true results and how good these results. And see if it makes sense to combine this data, because it's a lot of work, and sometimes just the handheld, it's enough. This is another question that I want to solve. The place is in Jarandilla, in Spain, and this is the point cloud from the ALS. It's much less dense. We basically just have like ground points and canopy points, so we don't have much data from the trees, the diameters, the stem, all this difference. So what comes next in this field, in my work? I need to collect some data in this area and do all the processing, the pre-processing, the merging data, and compare the results. I did in another martelloscope, but for Jarandilla, we're planning to do next week. So that's it. Thank you.